wasn't anything like a psychedelic society. The idea would have been unthinkable somehow in 1989 for the university to even allow that. That's a sign of things having changed over the last 20 years or so. But the only thing which you could have called heretical, I think, back then, that I remember was a parapsychology society. I remember seeing a poster for a UK parapsychology society. And I remember being outraged, because I was a very different person then. I was young, I was very sure of myself, I was studying mathematics, and I was sure that maths and science explain everything. I was one of those skeptical reductionists. I wasn't part of any sort of organised skeptical thing, but just my personal orientation was, I don't believe in any of that. It's outrageous that the university should allow a parapsychology society, and that means some academic is actually sponsoring it. Just, I wasn't outraged enough to start a campaign, but I remember being shocked. Anyway, that was before I was exposed to psychedelic culture and thinking. And by the time I was doing my PhD, which was also here, that had changed. I'd become exposed to those things. And I was a bit less willing to dismiss things. My sense of reality had perhaps broadened. So the idea of parapsychology didn't seem so outrageous to me. ESP, telepathy, psychokinesis. It didn't mean I believed in them all, just that I wasn't going to just laugh at the very idea of them. And I ended up reading something, I can't remember where it was, about psychokinesis experiments in the 70s. And psychokinesis, you probably know, is what's colloquially called mind over matter. And in its sort of cartoon form is when I sort of send out waves from my brain and make this thing move across the table. That's not something that happens very often, if at all, and so it's very hard to study it in the lab. There's anecdotal evidence of such things. But what you can study, that's called macro psychokinesis. Micro psychokinesis, again, I'm not saying I believe in any of this, just telling you what people are studying. Micro psychokinesis is when you can supposedly influence events at a much smaller physical scale. So the classic example is a random number generator. You have an electronic device, it could involve radioactive decay, sort of Geiger counter kind of thing, or it could involve noise diodes. In both cases, you're using a sort of quantum-based level of reality to create purely random output. You can't possibly predict, there's no patterns, and you just make it spit out zeros and ones, and you get somebody to focus on a screen where there's like maybe two different coloured lights, or you're hearing two sounds in each of two headphones. And this is being driven by the random number generator, and it's your task to try and skew the distribution one way or the other, more this way, more that way. And it seems from some of the micro-psychokinesis stuff that I was reading from the 70s, from seemingly the more reputable researchers, of course they're all accused of being frauds and making it up and being sloppy by people who have decided already that that's the case, and there are people like that, and they do organise into groups, and they do edit Wikipedia pages very vigorously, which is an interesting social phenomenon. They might be right, but they're very organised about it. Anyway, so micropsychokinesis, I was interested in this mainly when I found out that Helmut Schmidt, a German researcher, there was a German chancellor and statesman of that name as well, but this was just a minor major parapsychologist, but not a household name. And he discovered that these random number generators could be seemingly influenced by certain people. And what we're not talking about skewing the distribution from a 50-50 output, if it's spitting out zeros and ones like tossing a coin. It's not like someone's able to make it go 80-20 or something. It's not that kind of like superpower thing. It's more maybe 50.5, maybe 50.2, but over a very long time. This is the important thing. If you just did that for a little while, it's like, well, yes, of course it's never going to be exactly 50%. But if you can hold it at 50.4 for a very long run, that's statistically hugely significant. Any of you who do any kind of statistical analysis know what I'm talking about. And that's the kind of research that was going on. And it seemed that these effects could go on even if the data was pre-recorded, even if the zeros and ones that were being received by the subject in the experiment that they were trying to influence were coming off a tape that had been recorded a week ago or a month ago or six years ago. It didn't seem to matter, as long as no one else had observed it. If it was unobserved data, it was easy enough to do, just hook up your machine to a tape machine, and then you put it away in a vault, you get it out, and you have someone do the same experiment you've been doing with them before, where they were using like live random number generators, but now it's stuff that was pre-recorded, and they don't know that, and they're trying to influence it. I mean, they're not even thinking about random number generators, they just see these red and green lights or something, and they're just trying to, it's like a psychic video game. And it's fun to do this, and I've got involved in it myself, as I'm going to explain, because I found out that Helmut Schmidt's retropsychokinesis research, well, when I found out about it, I realised that the World Wide Web, which had just become a thing, this is like 1996, I finished my PhD, and I was just sort of floating around thinking about things which interested me. And the web had come online, which was a fascinating thing at the time, completely uncommercialized at that stage and full of sort of visionaries and a very optimistic sort of community. And I saw the potential for the web as a very sort of accessible and open, verifiable framework within which this kind of research could be done. So rather than having to bring people into a laboratory and say, right, now sit in this chair and I'm going to set you up with this thing, and then having to publish my research and then deal with people that are saying that I'm fraudulent or that I'm sloppy in my experimental methods and disbelieving me anyway, and also people being nervous in that role as subjects in an experiment like that. I had this idea, well, with the web, you could run the same experiments using a website. And this is what I did in 1996, so only a few years after I ridiculed the idea of there being a UKC Parapsychology Society. I came back here, humbled, and I'm looking for a website with a PowerPoint slide, here we are. And Peter Moore, I think may still be here in the Religious Studies Department, if not, he was until quite recently. Do you know Cameron?
No, I don't know.
He's some of those reading groups we went to, he used to show up. But he didn't remember me, but back in '96, he agreed to sponsor me as an outsider. I mean, I wasn't really affiliated with the university. So as part of the School of Classics, Philosophy and Religious Studies, I was running this completely insane-looking parapsychology project online. And he was happy to sponsor that. He was the one that was the sponsor of the Parapsychology Society. And the idea was to run experiments whereby there were 3 experiments. These were written as JavaScript applets, which I commissioned. And the idea in this one is you're trying to get this line, this vertical line, to go left or right. In this one, you're trying to get the clock to go clockwise or anti-clockwise, or I think maybe speed up and slow down. And with this one, you're trying to get the pendulum to swing wide or narrow. And in all cases, what you're seeing is being driven by a bunch of random zeros and ones, which were recorded ages ago. It was a Geiger counter in Switzerland in 1996. Hooked up to a computer, basically with some strontium, measuring radioactive decay, which is the most random thing in the universe. It's what's being called God's dice. You cannot in any way predict the timings of radioactive decay, so they make very good random number generators. So if I were to run one of these, which unfortunately, because I wrote this is like web archaeology, this is from '96, sorry, it appears your browser doesn't understand Java applets. I've tried it in all different browsers. I wrote this, or the person that wrote this wrote it in a version which is long dead. Now, this thing was running for about 15 years. Last time I checked in with it, about 5 years ago, it had been referenced in various parapsychology literature. It had gathered a huge amount of data, because basically anyone could just stumble upon this site, which just looks kind of weird and interesting. What's this about? Go to the experiments, and suddenly, before you know it, you're running an experiment. And if you want to, you can put your email address in, and you can basically clock up lots of experiments, and it can sort of notice that certain people have got seemingly abilities which could be studied more closely. But the problem was, I just stormed into the parapsychology scene like a bull in the china shop. I hadn't really looked at how things were done, and a lot of the established experimenters were sort of horrified that this young idiot had just basically just stormed into the web with this massive sort of global experiment which had no sort of sensitivity in terms of like screening people. It's just open to everybody, so that any data you get is going to be totally diluted, and they had various other criticisms. And I wasn't convinced that retropsychokinesis was real. I simply could see that there was a way you could test it in a completely verifiable way, so that any skeptic, you could say, okay, you don't believe this, I've got somebody here that can influence this pre-recorded random data, you don't believe me? Let's generate some data now. I take a copy, you take a copy, lock it away, get my experiment to run. The person seemingly influences the data, now look at your data, bam. That would be the cartoon version of how you could prove to somebody who really wanted to know that it was genuinely happening, and you don't have to have any oversight in the experimentation. So this was my big idea, and there was a kind of I think crazed sort of Gnostic activism thing going on at the time. So this is 20 years ago, and I felt that if there was something in this, and having been exposed to psychedelic thinking and consciousness, and culture, it seemed quite reasonable to me that something like retro-psychokinesis, that the future might be somehow influencing the present, or that the present might be somehow conditional on the future, and thereby the past on the present. That didn't seem so insane to me, and I thought if I can prove to the world conclusively that this is going on, that's going to bring the walls of consensus reality crashing down, and that was my biggest kind of ambition, I think. Which sounds a bit crazy now, but I was getting quite impatient with the world for being stuck in this consensus reality, and I wanted to do something about it. But eventually I realised I hadn't really gone about it in a very helpful way, but I thought, well, I'll let the experiment run, and as I said, it ran for about 15 years at least. But what I was left with was more an interest in alternate models of time. In the process of putting the site together, I collected lots of literature, so that site, what's good about that site is it's got a big set of links. Well, a lot of the links are dead. This is, as I said, like a 20-year-old site. But it's got resources which are still stable and live. And one of them is a bibliography that this German ally put together for me. And you know, I'll just scroll through it. I mean, if you're just defending backward causation, time asymmetry, time reversal, irreversibility, these are things in physics journals and philosophy journals. This isn't sort of wacky stuff. Right? Almost everything in this bibliography has got something to do with backwards time, multi-dimensional time, imaginary time in the mathematical sense, fuzzy time, fractal time, you know, the arrow of time. There's a lot of it. And so I just got interested in the idea that time might not be quite what we're told it is, what you could call temporology. And I was getting all of these ideas together, this idea of this parasite, this retro-psychokinesis project. I got this together just after I'd been to Mexico. And this is the thing I'm best known for, which is sort of unfortunate, but it's just the way things were, the way things happened. And I've talked about this so many times already to people that it gets a bit tired, and you can check it out online if you want. But Terence McKenna, a lot of you, those of you from the Psychedelics Society, and I think there's some Philosophy Society people, Terence McKenna, if you didn't know, was a sort of maverick psychedelic philosopher, very entertaining character, not totally believable in everything he said, but you know, worth checking out if you're not familiar with him. And he and his brother went to the Amazon in the 70s looking for, basically looking for ayahuasca, but ended up finding psilocybin and taking huge doses and having heroic type experiences, as he described in these sort of, you know, a 40-day trip in communion with the universal mind, supposedly, wherein it was revealed that there was a map of time to be found in the I Ching, the Chinese oracle, and Terence this was 75, nobody noticed, this book just came and went, hardly any copies sold. But then it got sort of rebooted in the 90s like this, and the mathematics had been slightly influenced, it had been updated and influenced by fractals, and it had a sort of snazzy endorsements on the back from some interesting kind of popular culture figures. And he was suddenly on the lecture circuit, and he was promoting psychedelic culture, and he was making collaborative records with electronic music dance producers. He was kind of a name on the scene in the 90s. He became kind of like the new Timothy Leary, if you like. But I was interested as a mathematician. I was interested to hear what he had to say about psychedelics, and a lot of what he had to say was fascinating, and there was no one else out there saying these things as eloquently. But he had this idea about this fractal time wave, this thing that was buried in the I Ching. And here he is, pointing at his computer software back in the early 90s probably, showing this fractal graph that he constructed, starting with this. This is the sequence of hexagrams in the I Ching, the King Wen sequence. If you don't know the I Ching, it's a Chinese oracle, a sort of fortune-telling device with 64 chapters. Each one's represented by one of these symbols, which is made of 6 lines, so there are 64 of them, because each line's either yin or yang. And it's a puzzling sequence, there's no obvious pattern in it, other than that they come in pairs, obvious pairs geometrically, but other than that, it's not clear why they're in that order. But it's a very old sequence. And the mushroom logos, as he called it, told him basically to look into that for a map of time. And he made this graph. But this is the number of changing lines between these hexagrams in sequence. If you count how many lines change from one to the next, and you make a graph, you get that. Now you might think, why would you do that? But that's what he did. What's interesting is that he took that and then he flipped it upside down and made a backwards copy of it, and then he combined them, sort of meshed them on top of each other, and then stretched them and rescaled them several times in a way which was sort of linked to the I Ching, but in a sort of quite sketchy and arbitrary way. And he made this thing. And he said that this was like the basic unit. This is the sort of the shape of time which operates at all scales, microseconds or billions of years. And so that you have to layer it on top of itself in all scales. So he built this kind of fractal wave, which looked like this. Now, as I said, it wasn't really like that in the original book. It kind of got tight. It got sort of ameliorated in the intervening years, and he wasn't really straightforward about that, which was, you know, a bit of a problem. But it was made to look as if he'd stumbled upon the idea of fractals before everyone else had on a mushroom trip, which wasn't really the case. But the idea resonated. I could see the idea of fractals resonated with him because he was talking about something like a structure within time that operated at all scales. And by iterating it in the way he did, he ended up with the whole thing crashing down to zero. Now you might think, what's this representing? What's this up and down thing representing? This is supposed to be historical time. And it was what he called novelty, and he was interested in the ingression of novelty into the world. And the idea, the reason I'm talking about this in a talk about retrocausality is because the idea is something that there's an ancient Greek word eschaton that he liked, eschatology, roughly meaning the end of the world. But the idea that there was a point he predicted in December 2012, this is the bit you've probably heard of if you've heard anything about him, the end of the Mayan calendar, or the end of one of the big cycles anyway. It's come and gone, but he died in 2000, and in the 90s, he was basically saying that point there where this wave goes down to zero is what he called time wave zero. This is when you get an infinite level of novelty entering the universe. And this is where there's like a singularity beyond which you can't sort of predict anything. And he didn't actually say what would actually happen. He let people sort of speculate on that. He threw out some ideas. But he was basically pushing a kind of really interesting psychedelic end of the world scenario that a lot of people bought into, because it was like a good end of the world. It was like to get more and more amazing and kind of hyperspatial and expansive in terms of possibility, and just blasting off out of the bounds of normal space-time into something unimaginably psychedelic and beautiful. Seemed to be the sort of the optimistic sort of description that I was getting. He was promoting this very, very powerful psychedelic called DMT, which he felt was sort of making this clear to anyone who took it. But the date itself, fixing that date was problematic because the date came and went, and now the idea has been discredited. But I delved into this. I was the first person who actually bothered looking at it. I was like, how did he get that? What's going on here? And he provided me with the original manuscripts and the computer code that was used to generate the wave. And there was just some problems with the way he did it. It was a bit arbitrary, and he didn't explain all his steps. So it got sort of discredited, but that's not really the point. The point is that he, as a psychedelic thinking person, very psychedelic sort of typical example of psychedelic thought, I think, Terence McKenna, was very open to the idea of time flowing both forwards and backwards, because this is representing change through time. So this is representing a backwards time, and the idea of these meshing together just seemed natural to him. It seemed evident that that must be the way it was. And when I met him to discuss the problems with his theory, at that time I was just about to set up my retro-psychokinesis project, and he was really into that. He was, we talked very enthusiastically about the idea of the future somehow influencing the past, or the present, because he saw that we were being pulled into this kind of singularity, that there was this event, this hyperspatial event, he called it, at the end of time. And this acceleration we're seeing with technology and culture and everything just getting more and more complex and dense and interconnected. He saw that as, you could almost track it on a graph, and you could see where it was going to hit the infinity, and that's supposed to be here, but it didn't quite work. But a lot of it appealed to a lot of people. It appealed to me, the idea at the time, but I wanted to check it out. When I checked it out, I wasn't terribly impressed, but I wouldn't dismiss Terence McKenna entirely. He has a lot of good stuff to say, or he did. And if you don't know him, do have a listen, but don't take the time wave stuff seriously. But the reason I brought him into it is simply because he's, as I said, one of the big names of psychedelic thought, and the idea of retrocausality seemed perfectly obvious to him. And he promoted this idea of a future event pulling us towards it, and that was very popular with the psychedelic community. So there's something going on in terms of psychedelic psychology, the psychedelically experienced mind, and these ideas, which is an interesting thing that perhaps somebody in the psychedelic research community might want to look into. But the arrow of time, now this is where we get into this is the current thinking on time, and whether, the idea that there might be some sort of backwards time effects would normally fall into this sort of category. That question would be considered. within the philosophy of science, not really within science itself. Science gets on perfectly well with its equations, but the philosophy around what it all means has arrived at this concept, the arrow of time. So I'll explain what I mean by that. I won't talk about that quite yet. Basically, the laws of physics, pretty much, with a couple of exceptions, which are very interesting in themselves, are the same forwards as backwards. So what do I mean by that? Okay, I'll give you a couple of quick examples. I film a pendulum, just a well-lubricated pendulum, just swinging. I film a few seconds of that and I show it to you. Can you tell if the film is going forwards or backwards? Anyone think you can? No. The only way you can tell if it's going forwards or backwards is if the film's long enough that you see it losing the width of its swing, because it's running out, its friction is causing it to lose its energy. But if it's a short film or a very, very perfectly tuned pendulum, you can't tell. Similarly, if I had a pool table with no pockets, and I set the balls in motion quite vigorously and filmed that for a few seconds, and you saw all the balls bouncing around and knocking off each other and going all over the place, can you tell if that's forwards or backwards? No, you can't, because the laws, the mechanical laws governing these types of things, they're equations. You might not be familiar with what the equations are, but you're more kind of familiar with the fact that there are equations that describe this stuff, and they have a variable t in them. Invariably, they have a variable. That's not the right adverb. They always have a variable t, which represents time, the flow of time. And if you just change the t to a minus t, you get the same system running backwards, and it always works. As I said, in almost every area of physics, the laws of physics are the same forwards or backwards. Now, if I throw something in the air and catch it, and film that, same thing. You can't tell which way you're seeing that. It's totally symmetric. Now, but what about if I dropped a brick on the floor, and I filmed that, and I showed it to you? Yeah, can you tell which way the film's going down? Of course you can. Nobody ever sees a brick suddenly leap into the air into somebody's hand, ever. And yet, that does not violate the laws of physics. There's nothing wrong with that film. If I showed you the backwards version, it could actually physically happen. It just is incredibly improbable. And this isn't some quantum thing. This is just physics. This is just mechanics. This is really basic stuff. Here's how it works. I drop this brick on the floor. Gravitational energy causes it to go down, hits the floor, makes a bang, which is sound energy. It's pressure waves in the air. It makes heat, which is molecules jostling around it on the floor. And it also makes mechanical waves in the floor. It makes the floor vibrate, and you can see that it's a floor made of something a bit more flimsy. Okay, if I show you the film backwards, and the film isn't just like a camcorder thing, it's like a full 3D multi-sensory experience. What you would see is a brick sitting on the floor, me standing like this, and some waves would suddenly come towards the brick. A sound pressure wave would go backwards at the brick, like a kind of reverse sound. You'd hear a kind of backwards explosion, backwards banging sound. And a load of heat energy would suddenly congregate around the brick. I don't know if energy can congregate, but you get the point in. All of that energy would add up to enough and it would be in the right direction if you added up all the vectors, to throw the brick into the air exactly to that height, and I could catch it. So that could happen. It's never going to happen in the history of the universe. The probability of it happening is so small, it's ridiculous, but it doesn't violate the laws of physics. So what's this telling us? We can see a direction in time. If we can watch something long enough, the pendulum swings down to nothing. The balls on the table stop moving. Something falls down. Something runs out of energy. If I mix white and black paint in a bucket and film that, it mixes up into a sludgy colour. If I film that backwards, you never see that sludge separate itself out. But it could. All those molecules can do whatever they want. They can go anywhere. And there's no law of physics to say they can't all the white ones can't go over there and all the black ones over there every now and again. If you sat and watched that bucket for eternity, that would happen every now and again. So what this means is that any sense of directionality in time is tied up with probability, and that's a problem because that's kind of a human concept which is constructed on top of time. So here we go. This is the standard stuff you see in thermodynamics. If anyone says, I know there's at least one physics student in here. So this is how they teach you thermodynamics. So we've got some gas in a box represented by some blue dots, which represents loads and loads of molecules. We take the partition, they're all bouncing around quite vigorously, and we take away the partition. What we would expect to find if we went off and made a cup of tea and came back would be something looking like this. Not exactly like that, of course, but just looking kind of random and spread out. Of course it would. Well, there's nothing to say that those blue dots couldn't have all ended up on the other side. or just stayed where they were, or gone into stripes, or spelled out my name. All of these things are possible, but just probability is very small. Because almost, if you made every possible configuration, you made a mathematical description of every possible way that that box could look, where every possible combination of positions was represented, within that would be everything. Some things which would just look silly, like you wouldn't believe that that could happen, but they would be in there. There just wouldn't be many of them compared to most, almost all of them would look like just a random mess. So if I show you a film of half a box of gas filling up the box, you think, well, that's obviously going forwards. If I show you a film of a box of gas compressing itself into one half of the box, or spelling out something, in Cyrillic, you'd think that's obviously going backwards. That's, that couldn't possibly be the case. But it could. It's just unlikely. And similarly, mixing. That's another way of representing this process. Now, this is the process called entropy. It's quite a difficult concept to get your head around. It's, again, sort of philosophy of science, but it does come into thermodynamics. It's kind of things losing structure, things mixing, things going to a state of kind of sort of maximal randomness. I mean, it's difficult to give you a technical definition, but again, if I separate the partition here, you'd expect the blue and red dots to mix together. Like I said about the buckets, the bucket of two coloured paints, they don't unseparate, but they could. Now, Arthur Eddington, he was an astronomer. He was the one that came up with the idea of the arrow of time. And these are the three things he had to say about it. Now, this is fascinating to me, because the first one, okay, we can all see that. We all know about it. We all know which way time's going. Me coming in this room happened before now. It didn't happen. I was conceived before I was born. There's a sense of direction in time. Things happen in an order. We all know that. And number two extends this. We recognise it. We don't just recognise it. We need it in order to think clearly about anything. Again, if you show someone a film of reality backwards, it looks crazy. We just expect there to be a kind of, well, our reasoning is all based around time going in one particular direction, and that's the direction which ties in with the entropy direction, the things getting more disordered and mixed and spreading out. That's the direction where the brick falls, it doesn't throw itself in the air. That's the direction that makes sense to our reasoning faculties, he observed. So these aren't scientific observations really, they're about the mind. And the third one is again, in a more subtle way, about the mind. It makes no appearance in physical science. There is no arrow of time anywhere. Like I said, all the laws of physics are the same forwards and backwards, except in the study of organisation of a number of individuals. And that's like, okay, a load of molecules in a box of gas. A box of gas consisting of a load of molecules. It's a number of individuals. Look, there's lots of molecules, we can count them, they're all roughly the same. But that requires there's some sort of overlay of consciousness onto that. That's not looking at things as they are. That's us dividing reality up into categories of things and counting them and pointing at them and organising things or understanding things in that way. It's problematic in order to really pin down precisely what's going on with entropy and with these sorts of attempts to quantify this process which we associate with the directionality of time. It is tied up with some philosophical problems which I think haven't been properly addressed. I mean, there are philosophers of time talking about this sort of thing. But basically, all of the characteristics of this arrow of time are to do with us, really. They're to do with our relationship with reality, as opposed to something which is actually intrinsic in the universe if you took us out of the picture. If you took us out of the picture, really, there's no direction. Except you could say no, there is, because the gas fills up the box, it doesn't compress itself. But if there's no one there observing it, I haven't really put these thoughts together in a way which is coherent enough to deliver them in a way I'm happy with. But I think you can sense there's something weird going on with this stuff. There's something interesting which hasn't really, I don't feel has been really addressed properly. So the thermodynamic arrow of time is the one where things mix up and run out of energy and wind down. And that's the one that we associate with common sense. There's also a cosmological arrow of time in the sense that the universe appears to be expanding as a result of the Big Bang. That's the current model of reality we've got. So it was a Big Bang about 15 billion years ago. Is it 1346? Something like that. So anyway, a long time ago. Everything's still expanding. So if you watched a film of the universe, you can say, well, the galaxy is expanding or contracting, moving away from each other or towards each other. That gives you a sense of something in a certain direction. That seems to run in the same direction as the entropy.
And then there's something else called the quantum arrow of time. I'll come back to this. You may have heard of something called the collapse of the wave function if you've read around any kind of popular account of quantum physics. And that's something which that has a direction. There's a directionality about that. It's something which happens. It's a before and an after. But it's tied up with epistemology. It's tied up with our state of knowledge of the system is part of how it is quantified. I think that's what I was trying to say about the thermodynamics. So all of these things are, well, they're all fascinating to me, but these all line up as they're currently formulated. They all line up with the psychological arrow of time, the common sense one. But now let's just look at causality. So here's 4 definitions. I won't read them out. You can just kind of browse them. 4 definitions of causality I found very quickly, just looking at some respectable online dictionaries. And I grabbed these 4, and they all make sense. They're all basically saying the same thing in slightly different or more elaborate ways. Can anyone see the obvious oversight, the thing which is the elephant in the room, which is not being observed, which isn't being noted? Think about what I'm here talking about.
The cause and effect.
There's no sense of direction of time. It doesn't say anywhere that the cause happens before the effect. We take that for granted. We take that for granted to such an extent that the definition doesn't even bother to tell you that. There's nothing in that suggests that you couldn't have a cause in the present somehow influencing the past. So that's just an illustration of how embedded the thinking is, that causality is a single directional thing. But David Hume, philosopher in the 18th century, has some very interesting things to say about causality. Now, this isn't his words, this is someone else's. I'm not sure, I can't remember which commentator what this was. I should have put in a reference. But they're pointing out that the problem with using causality as your sense of the direction of time, so you knock something off the table, it falls, it breaks, I caused this to happen and therefore time's going that way. The problem is that you can't perceive a causal relation. It's not a tangible thing. It's just a sequence of events. And I remember being told about some psychology experiments, again, I can't give you references, but where people were presented with sequences of events which were set up very cleverly to look like things were causing other things, but they weren't. They were all separate, independent things. And when someone was asked to describe what happened, they adamantly defended the fact that these things were all a sequence of causal chain of events. That's how we see things. But that's not in the world, that's in our minds. Causality is basically a sort of storytelling device. It's a narrative device. There is no law of causality in physics, really. You have to introduce it yourself. And Hume went on to say, it's hard to, you can't really define what a cause and effect really are, and you can't really pin down what they refer to, because any physical event, at our level of what I think anthropologists call chunking reality, we break it down into objects which we name, and then we have stories about the relationships between them. In that kind of world, there's sequences of causes and effects, because we're basically in a story. But if you looked at the world as just a swirling mass of fields and particles and energy and matter, you don't see these clear boundaries between things. Everything's just a big fluid that's following seemingly some dynamical laws. So you don't need to chop it up and say, there's the cause, there's the effect. I mean, if you're looking at water flowing around in little whirlpools and eddies and things going over rocks, you don't say, oh, that bit of water just caused that to do that. The whole thing's causing everything to do everything else. So Hume basically criticised the idea of causality back in the 18th century, but it is the basis for how we see the arrow of time. And we're going to come up to we're now coming on to the idea of retrocausality. And of course, I had to sneak in Salvador Dali. Now this brings us back to this whole psychedelic philosophy thing, in that Dali, as far as we know, he never took psychedelics. He famously said, I don't do drugs, I am drugs. Take me, I am the drug. Take me, I am hallucinogenic. But he also said everyone should eat hashish, but only once. And he shot a sort of fake documentary with a filmmaker friend about an expedition to Mongolia in search of giant hallucinogenic mushrooms. So he was certainly interested in these things, but he was painting very trippy art well before he would have had access to any of this stuff. He was just naturally in tune with sort of the dream level of reality. And as a result of that, people on psychedelics, generally sort of go through a Dali phase, and they quite like this. But the melting clocks are one of his, if you almost had to pick one image that you associate with him, it's the melting clocks. And what's that about? It's about time being fluid and time not being quite what you're led to believe. In a dream, time can kind of go floppy. So here's the persistence of memory, the famous one. And then this is the sort of remix, well, there's several remixes, but there's the, what's it called, the coloured chromosome in the fish's eye, initiating the disintegration of the persistence of memory. And then he's gone into detail with part of it. But it's, again, the fact that people who had exposure to psychedelic consciousness and thinking seem to be quite okay with the idea of time being something more fluid than this rigid linear thing that we're generally educated to think it is. And I'll say more about that. So some anecdotal accounts of responses to these sorts of things among the psychedelic community. But I'm going to talk about a couple of pre-psychedelic thinkers from the 20th century who were very interested in retrocausality. Luigi Fantapié, I didn't know about it until recently. I've been revisiting ideas from 20 years ago. I don't talk about this stuff all the time. This is just something I've dredged up from the past. But he's a legitimate Italian mathematician. He created this theory of what are called analytic functional, so it's definitely legit. I don't know much about him, but I know he's not a fraud as a mathematician. His work is completely integrated into high mathematics. But he came up with this idea of retrocausation, well, it starts like this. Everyone's seen this equation. It's probably the most famous equation in the world. If you had to name one equation, you'd probably name that one. So you've all seen that, but have you seen this one? How many people have seen that? Yeah. Now this one is where the first one comes from the second one. The second one is derived, and then in the particular context which Einstein was interested in talking about, P being momentum, was 0. So this P squared C squared thing becomes 0, so you can just get rid of it. And you get E squared equals M squared C to the 4th. So don't panic, I'm not going to suddenly start talking about higher maths and physics. Simple stuff. So I basically cross this bit out, and I'm left with that. Now if you have E squared equals M squared C to the 4th, anyone who's done a bit of maths knows you can take the square root of both sides and get E equals MC squared. But if you're paying attention, you're aware there are two solutions. There's a positive one and a negative one. So say x squared equals 4. You know anything at all about algebra, you know that there's not just one solution and x equals 2. 2 squared is 4, of course. But minus 2 squared is also 4, so there's a plus and a solution. So Einstein was aware that there was also a minus solution to this equation, a negative version, a sort of mirror, but it would involve negative energy. What would that be? A negative mass, and it would also involve things going backwards in time, by implication. So this was obviously nonsense, and he just said, well, we just ignore that, because that's just a physically impossible thing. And it got ignored until Fantapié had a look at it, because this was fine until he started trying to apply this new relativity theory Einstein had down to quantum mechanical matters, where you have things like electrons spinning close to the speed of light. So you have to start doing E equals mc squared type magic on them. And suddenly, this P thing starts to matter, and you've got to go back to this, and the negative time solution suddenly starts to get all tangled up in what you're doing. And I'll say more about this later, about negative time mirroring forward time, backward time waves in quantum mechanics and certain ways of interpreting that. But this thing called the Klein-Gordon equation, it just basically is crying out for a backwards time component, which makes sense of a lot of things. But Fantapié could see all this, and so by 1942, he'd written a book called The Unitary Theory of the Physical and Biological World, in which he was arguing that life, as in biological life on Earth, is being caused by the future. Now, obviously a lot of people, well, I would guess a lot of people thought he'd just lost his mind. Life is being caused by the future. But he was thinking like this. Entropy is the thing I was telling you about, where the gas particles all spread out and just become more and more sort of random and disorganized. The thing that allows you to tell which way time's going. And he's like, yeah, that's what you see in most parts of the universe. Everything just kind of disperses and falls out and becomes, runs out of energy and wears out and rusts and falls apart. That's the way things go. But there's one area of reality where it's not like that, where things become more and more complex and organized, and that's in biological world. Things have gone from single cells to higher mammals, and those higher mammals are now starting to create civilizations and technologies, and this is the sort of Terence McKenna stuff. He loved to go on about all this. So we're seeing the opposite of entropy going on in a limited bubble of reality on the surface of the Earth. We're seeing a total reversal of entropy. Now the thermodynamics people wouldn't say, oh, they would say that's not a problem, that's not violating any laws. You can pass this cup round, I think people are going to put stuff in it if you want to just pass the cup round. It's not violating any laws, it's, where was I? Someone remind me, what was I talking about?
Entropy and how biological...
Oh yes, yeah, you can have a reverse, you can have the opposite of entropy going on locally, because it's not a closed system, it's part of a bigger system, and within that they would claim the reduced entropy we're seeing. The reduced entropy we're seeing in the biological and social and cultural and technological world, they would say, well, that's being compensated for by gains in entropy that are being created by all this heat that's being let off by these factories and all this pollution and general disorder that's produced. There's some clever arguments which basically tell you there's nothing, it's just a little localized phenomenon that balances out overall, that's the idea. But Van Tapier wasn't convinced by that. He came up with the idea of syntropy, which is basically the opposite of entropy. It's a really nice word. You sometimes see the words negentropy and extropy as attempts to kind of come up with the opposite of entropy. He wasn't the only person to think like this. I think various people define it in slightly different ways. And entropy is a tricky one to define. You can define it in terms of boxes of gas, but you can also define it in terms of strings of random numbers, and there are multiple definitions, and there's philosophical debates about where they overlap, so it's a thorny matter. But the general idea is entropy is stuff just thinning out and wearing out and running down, and syntropy is things coming together and organising. And he's saying, okay, most of what's going on in the universe is entropy, and that's been driven by the forwards time laws of physics, if you like, by the forwards time components of the mechanics of the physical world. But we're also seeing something which appears to be being pulled from the future. And life is being caused by the future, is what he said. The syntropy we're seeing is being caused by mirroring laws of physics, effectively, ones which mirror the entropy generating ones. Another person around the same time, well, he was born earlier but died around the same time. He was pushing similar ideas. Now again, I'm not endorsing any of this, it's interesting to know what's out there. Jesuit priest and a geologist, paleontologist, and philosopher, Teilhard de Chardin. He came up with the idea of this thing called an omega point, and Terence McKenna had, owed quite a lot to this idea. McKenna was interested in a lot of different types of eschatology, but he was aware of this omega point idea. And it was basically a melding of Catholic theology with Darwinian evolution in a way which basically upset both the reductionist reductionist biologists like Richard Dawkins, being the classic example, was seen as a charlatan by the hard, real scientists. But also, no, he wasn't excommunicated, I don't think, by the Vatican, but his books were removed from Catholic libraries by order of the Pope. Because he basically bridged theology and evolution theory in an interesting way. And he basically said, okay, so we are seeing evolution, the evidence is showing it, let's not deny it. We're seeing cells, becoming multicellular and evolving into these higher organisms, and then us. And he basically saw an evolution that went beyond biological evolution from primordial particles to the development of life, human beings, and the noosphere. That's the whole kind of web of human communication. And this idea that we're going from a geosphere to a biosphere into consciousness in humans, and then onto some sort of supreme consciousness, and this is where it gets religious, this idea of this, almost like we're creating God as some future point or something like this, or God is something in the future pulling us towards a state of perfection. He was pushing a really kind of, almost like a sci-fi theology. It's quite cool if you're able to stomach Catholic theology. It's among the kind of the most psychedelically compatible. And now we leap ahead into the second half of the 20th century, and here are three people that definitely are psychedelically experienced, or were. Terence McKenna's gone now, 2000 he passed away. Rupert Sheldrake's still around, and some of you I'm sure know about him. He's a kind of radical biologist. McKenna is a sort of maverick psychedelic enthusiast. And Ralph Abraham was a dynamical systems theorist, a physicist who was one of the pioneers of chaos theory in California back in the 60s, and he did some very serious research, made some real breakthroughs, and he's one of the very few people, interestingly, in the mathematical sciences that I'm aware of who's openly psychedelically experienced, or at least he was when I used to be interested in that kind of thing. Probably now there's a younger wave of people who aren't prepared, who are trying these things and not afraid to tell people. But back in the 90s, there was no one else apart from Ralph Abraham. And these three were friends, and they used to get together and have these three-way conversations, which are great to listen to, because they all kind of listen and they all respond in interesting ways. Trialogues at the Edge of the West and Trialogues at the Edge of the Unthinkable were published as books of transcripts, and there's also loads of audio. Give you some idea, there they are. On Sheldrake's site, there's you can listen to, you can see some of the topics. It's a bit 90s, there's crop circles and fractals, and, but there's some good stuff. They're all, I'm not endorsing any of these people as to be absolutely everything that they say should be believed or taken seriously, but they've all got interesting things to say. They're all psychedelically experienced, and they all were interested in and were actively interested in their research in this idea of retrocausality. So we've seen how McKenna was with his time wave and this 2012 thing pulling us into the future. And Sheldrake, he's interested in morphology, embryology, the way things form. And so one of the things he's pointed out is that when you have creatures conceived, they begin as a single cell and then they multiply into multiple cells, and then they start to, certain bits appear, organs and parts. The standard model we're given for the metaphor we're given for what's going on is a sort of mechanism, more like a computer code. DNA is the code, and there's like the software that's been run, and the hardware is the protein molecules, and it builds this amazing thing. Problem is, if you've ever written any computer code, you know that if someone goes in and messes with a few lines, it's not like you run and you run the program and you get pretty much the right output. No, the slightest change of a semicolon messes the whole thing up. So the idea is some kind of nasty, not necessarily nasty, but a certain type of scientist I probably wouldn't be able to relate to. The type that take things which are growing and cut bits off to see what will happen. I mean, you learn things that way, but it's a the appeal. But what Sheldrake's interested in is the way that you can basically interfere with developing organisms, cut bits off and stick things in them and restrict them. Unfortunately, the pictures I've got aren't the best examples, but they seem to find a way around it. They seem to find a way of developing a full organism, in some reduced way perhaps, but they don't just go horribly wrong. If you do enough damage, they will, but it's a surprising amount of sort of self-regulation. You kind of knock it off its normal track and it kind of rebalances itself. And similarly with behaviour. So Sheldrake loves these examples of these very simple creatures, these wasps, brains the size of a pinhead, and they dig tunnels, they lay eggs, or they hatch these larvae, and then they build these partitions and they put food in sort of cells for them to gradually eat on their way out. And then they build this trumpet at the end to stop other predatory creatures getting in. And people have, again, in a sort of slightly, it's not malevolent, but, people coming along and not breaking them to see what will happen. You break them off and they just come back and keep rebuilding them. They'll just keep doing that until they run out of energy. But interestingly, if you make a hole here, they just come back and start building from that hole. And you might think, well, that's not hugely, but when you think about something, a brain that small is able to adapt to, first of all, it's able to know how to build something like that. We're told that a code, which is actually there's not that much of it. We've got less genes than a rice plant. And DNA, as Sheldrake likes to point out, basically just codes for proteins. It is more subtle than that. There are genetic activation mechanisms going on that can allow for some pretty amazing stuff to happen in terms of how those proteins arrange themselves. But in terms of a behaviour of a wasp, being able to basically improvise around a semi-destroyed structure that is built, Sheldrake's he's come up with lots. Those are just two, as I said, not particularly good examples, not striking examples of something that you can visualize using this kind of metaphor, what he calls creos. So it's as if these evolutionary pathways are like grooves in this downward sloping surface, and a ball rolls down a groove. If you knock it slightly on its way down, it will roll around a bit, but it's going to end up in the same place. It will regulate itself. Gravity is doing that in this case. But if you knock it hard enough, of course, it's going to go up over the edge and into another groove. And this kind of creo-based thinking is it's quite helpful for understanding things. The two things you can say about it, one is that it's suggesting things are kind of being pulled from the future into a particular kind of template or shape. And another one is, well, where is that? What is that? What's the substance of this thing? What reality has it got? Those are huge questions, but Sheldrake's done some, I think, really brilliant work and mainly raised really interesting questions. about things which seemingly can't explain mechanistically. But interestingly, he's taken psychedelics, and a lot of what he's saying in his latest book, The Science Delusion, which I highly recommend, he points out that, he argues that a lot of the things going on in embryology and morphology indicate something like a combination of mechanistic forward time processes, so cells dividing, things metabolizing and dividing and combining in various ways. But there's also something else seemingly these creodes. It's just a mental model that we've got at the moment. Something's in the future. You could think of it as some kind of idealized form of the thing. But again, what is that? Pulling it towards that future state. So you give it a bit of a knock this way or that when it's on its way. If it's got enough, if there's a deep enough groove, it's still going to get there. So McKenna, Sheldrake, both into retrocausality. Ralph Abraham, I discovered he credits DMT for swerving his career towards a search for the connections between mathematics and the experience of the logos, which is, you could argue, the sort of literally means the word, but sort of the universal mind. So he's a psychedelic mathematician. Someone's pointed out he looks exactly like Jerry Garcia from the Grateful Dead. He's a psychedelic musician from Northern California, very much from the same era and part of the same world. So he was kind of like, he was a psychedelic physicist, the archetypal one, and he liked hanging out with Sheldrake and McKenna and chatting about all kinds of stuff. But he was developing mathematics to describe dynamical systems which didn't fit into normal classical models, what's now called chaos theory. And a lot of it's based around these things called attractors. You've probably seen these because they're quite beautiful and they end up on magazine covers, but a lot of people don't really know what they're looking at, but they're lovely. But they're basically describing, they're what are called phase portraits. They're showing the evolution of a system. That could be anything. It could be a billiard table or a box of gas or a quantum mechanical oscillator. But basically you're tracking the behavior of something by representing it as a point moving in space, and it carves out these lines. So you can see something beautiful. It might just be a dripping tap, and you can still get these beautiful attractors. And the simplest way to understand an attractor would be a marble in a bowl, pudding basin. You drop a marble in, rolls around, what does it do? It ends up at the bottom. You spin it sideways, it goes round and round. What happens? It ends up at the bottom. Whatever you do, whatever path it takes, however interesting, it's always going to end up at the same place. And that's the simplest possible and very boring, most boring example, is what it ends up with is just a marble at the bottom of a bowl. A more complex system can settle into a kind of attractor where basically it can do all kinds of things at the beginning, but something seems to pull it into this groove where it then just stays in that groove. That's a very, very rough explanation of what attractors are, but hopefully it gives you some sense of it. And it gives you some idea as to why a psychedelic physicist who's working with this stuff might think maybe there's something in the future kind of pulling the system into it. So he's open to the idea of retrocausation. And he's been more recently, I discovered, again, this is all, it's only because Timmy asked me to give a talk that I know this stuff, so I'm very grateful. Thank you for inviting me, by the way. That was very rude of me not, so thank you at the beginning, so sorry. Physicist from India, Cecil Roy, and he had been getting quite mystical, but they know their physics. And they're talking about something before space-time, like a kind of what they're calling an ether. They're taking an old theological kind of term, but they're describing some pre-space-time something which kind of self-organizes itself into space-time. Really far-out idea, very psychedelic kind of physics. But notice the last sentence, with special emphasis on the illusion of time and the apparent paradoxes such as precognition, retrocausation, and entanglement. Now at this stage, of course, if you're a skeptical type who's never done psychedelics and doesn't really want to, and thinks that basically they're just something which distort your understanding of things, you could easily say, well, clearly all of these examples of these people I've given are people who just don't do any drugs and gone a bit crazy and this stuff's ridiculous. And that's fair enough, but check this out. Is this real? This is the point where people are saying, okay, it's all very far out, is it real? Dick Bierman, Dean Radin, now these are among the most respectable parapsychologists there are in terms of their experimental methods and their years of experience and the rigor with which they go through basically all the hoops you have to jump through to publish parapsychology research. It's much easier to get a drug on the market, honestly. You are subject to the most ridiculous levels of scrutiny because there's an ideological, basically, battle to push down any such ideas, it appears. Here we have some very respectable, I believe, researchers. who came up with this very simple idea. I think Radin started it, and then Bierman sort of executed it later. This was published in a journal, quite an unpretentious journal of perceptual and motor skills, not in a parapsychology journal. It works like this. You take people and you hook them up to a polygraph, like a lie detector, and that measures the skin resistance on your fingers, which is linked to how much you're sweating. That's how it works. If you lie, the little jolt goes through you, unless you're a psychopath, and then you can pick that up basically electronically and detect these little spikes in people's anxiety levels. So the idea is you take a collection of images, say 100 images, 90 of them are just innocuous household objects and pictures of trees and birds and things, and 10 of them are shocking. They're violent, they're pornographic, they're maybe horrible medical images of diseases and wounds and things that would make you sit up in your chair. And there's a computer hooked up to you with your polygraph, and it's got a clock, it's measuring everything to the millisecond, and beyond a millisecond probably. And it's randomly, the methodology is like this. You have a blank screen for 7.5 seconds, the computer randomly selects a photo, shows it for 3 seconds, and then you get 10 more seconds of blank. So you're basically sitting there waiting for the next image. It's either going to be really shocking or just boring. And if you get, what would you expect to see on the graph? You'd expect to see that after the event, you would see a spike. This is a shocking image, and this is a calm image. So you get a little bit of a bump when you see anything, just because it's like, oh, there's a picture on the screen. But if it's shocking, you get a bigger spike. Now that's what you'd expect. But what you see over here is that the shocking image creates noticeably higher levels of activity before it appears than the calm image. That's the gap. Now you might think, well, it's not much of a gap, but it's a perceptible gap that persists over many, many, many runs. It's statistically hugely significant, and nobody knows to sequence these images. It's not like someone sitting there in a lab who knows what the next picture is going to be, who's giving out signals. Nobody knows. The computer doesn't even know when that starts happening, when the stimulus is there. So this is going on before the computer even knows what the image is going to be. Not that computers know anything, but you know what I mean. Before the image is being generated. So what's going on? It's like it's as if the event, the shocking image, is causing an event, it's influencing you before you see it. Now, anecdotally, a lot of people, I think, if you just had a chat about this calmly with people, I think a lot of people might admit that anecdotally they kind of feel like this has happened to them, if they can relate to this idea, and that if someone's just about to knock over a beautiful vase or something, there's a sort of just a moment of dread, perhaps, before you even see them move. You know, obviously, if you see them about to knock it over, but just before things happen, sometimes there's a sort of little ripple of something, recognition. I found it tuning up guitars and stringed instruments. I don't know if any other guitarists could concur, but often when you break a string, broken strings often occur while tuning, and I've found that when I break a string, it always feels like some small fraction of a second before it broke, I knew it was going to break, but I didn't have long enough to put the brakes on with my muscles, so it was, I broke it. So it's as if the shock of the breaking string sends a ripple backwards through time. Now I used to go on about that to people, and it sounded insane, but this evidence, this experiment suggests that's actually probably exactly what's happening, in that string breaking is a shocking event. And the simplest way of thinking about this is, if you throw a stone into a pond, this is the mental image I tend to use, throw a stone in a pond, you will see ripples moving away from you as a result of that splash. The splash is a shocking event of some kind. But you will also see ripples coming towards you. But the problem is we have a psychological framework, and we have language structures which conform very nicely with the idea of the ripples going that way, which have made very little sense of the ripples coming this way, if there are any, and it looks like there are. They're muted, they're not as extreme, but they're there. And it's possible, because we haven't got words for them, we can't really talk about them, we sort of block them out. Although there is, and again, anecdotally, people talk about precognition, various types, sensing things, a sense of dread of something about to happen. Then, of course, you've got long-term stuff and prophecy and things like this, which, again, it's all tied up with this. But the Bierman-Radin stuff is a serious research of, very precise effects, talking about 300 millisecond type envelopes and things. But they published it as anomalous unconscious emotional responses, evidence for a reversal of the arrow of time. So these are scientists seriously suggesting some kind of reversal of the arrow of time. And this was presented at one of the third in the series in the 90s of down in Arizona consciousness conferences. People from all different disciplines, psychologists, philosophers, physicists, and mystics all getting together and talking about consciousness. And they presented this backwards time idea. Now, psychedelically speaking, I don't know Radin. I did email him for a while. We were communicating when I was doing that retro-psychokinesis project. He was very helpful and friendly. He plays the banjo. But Dick Bierman presented some of his research on the effects of THC and psilocybin on precognition at the MAPS, that's, if you didn't know, Multidisciplinary Association for Psychedelic Studies, at their conference in '99. So he hasn't done psychedelics himself, he's administered them to people in the lab and he's gone to a conference full of people talking about them, so he's obviously quite comfortable in that world. So we have, again, a sort of compatibility of psychedelic thought and the acceptance of the reversal of an arrow of time. Now, how are we doing for time, Timmy? Can I go on for another 5?
I don't know. Does anybody have time or not?
Is that right?
2017.
Yeah, we've got time.
Yeah, okay. So this is John Kramer, and I'll let him introduce himself for a few seconds. It's always nice to hear somebody's voice.
Right. So, hello. Okay, hi, I'm John Kramer. I'm a professor at the University of Washington. And in the 1980s, I invented an alternate version, interpretation of quantum mechanics. It's called transactional interpretation. And the basic idea behind it is that if...
Right, we won't get into the basic idea behind it yet. I'll run you through this in my own words, but he's sitting outside a conference here. Unfortunately, you can't hear him that well, but he's just introduced himself and got the basic idea. He's come up with a thing called the transactional interpretation of quantum mechanics. And the idea is that if you look at, as I said, I hinted earlier when I mentioned Luigi Fantapié, if you look at the quantum mechanical, or the relativistic version of quantum mechanics, you're combining Einstein's relativity ideas with the quantum mechanics that was emerging around the same time. You get something called the Klein-Gordon equation, and it's got a negative time solution which is usually ignored. And it can be interpreted, basically you can interpret the weirdnesses. You've heard about these sort of quantum paradoxes and weirdnesses. I'm sure a lot of you have heard Schrodinger's cat. The two-slit experiment, maybe you've heard about spooky action at a distance, or quantum entanglement, maybe if you've read around this stuff a bit more, Bell's theorem. Non-locality. There are all these problems, these paradoxes and problems with quantum mechanics and things which don't kind of make sense. The maths all works, but in terms of interpreting it, there are problems. Now, the mainstream interpretation is the Copenhagen interpretation, which was Heisenberg, make sure I don't get this wrong. I don't know my quantum mechanical history that well. Schrödinger and Heisenberg in the 20s in Copenhagen basically came up with the standard interpretation of what's going on. Now, the thing at the center of the problem is called the wave function. Again, I'm going to breeze through this. Don't try and, I'm not going to try and teach you quantum mechanics in 5 minutes. Particles, as you may have heard, sometimes appear to behave like waves, and they're not waves moving through space, they're probability waves in a mathematical hyperspace. And there's a thing called the collapse of the wave packet, and that happens when you measure something. So a particle exists as this kind of evolving wave in this abstract space, but when you observe it, you say, hang on, but where is it? When you look, you find it somewhere, and at that moment, the wave literally collapses down. Don't know why I used the word literally. I think it's all you young people are that was completely unnecessary use of the word literally. This collapse of the wave function gives us a quantum arrow of time. There's a sense of before, as I said, there's before and there's an after. But what's going on with this collapse? Why is an observer observing something causing it? And this caused the New Age crowd to get really excited. It's like, oh look, consciousness has a role in physics, and we can shape the world because the wave packets collapse when we observe them. Physicists hated the kind of New Age quantum mysticism, which was usually based on a false understanding of it. But their explanation, their Copenhagen interpretation, wasn't really helping because a lot of the paradoxes were still problematic, particularly to do with non-locality. And their interpretation was quite clever. They basically said this wave, this evolving wave function, it's not actually anything tangible. It just represents the state of knowledge of the observer. So if you don't know where something is, it's just in this kind of vague, wavy sort of state of indeterminacy. When you measure and find out where it is, that wave representing your knowledge suddenly goes down to a point because you know where it is. Before you don't know, now you do. So they're saying nothing's really collapsing. You're not actually influencing the universe. It's just a representation of your knowledge state. But it doesn't cut, you know, what's the expression, cut the mustard? It's not good enough. There are still problems. And Kramer comes along in '86 and comes up with a beautiful interpretation of quantum mechanics, which involves waves coming from the future interacting with waves going forwards through time. So there's what's called a retarded wave going forwards, which is a bit counterintuitive, and then there's the advanced wave coming forward. So if you look, he claims, if you look at a star 200 light years away, that wave has travelled 200 years to get to your eye and hit your cornea and register as light. But at the same time, well, somehow a signal, an advanced wave has travelled backwards in time 200 years from your eye to the star and interacted with the atom, the nuclei of the atom produced that original photon. He describes it as a handshake. It's a handshake between these forward and backwards waves. Now it might sound wacky, but it is actually completely, perfectly conforms to the mathematics, and it makes perfect sense. It makes everything really easy. He teaches quantum mechanics at Washington University with this approach. There's no problem, there's no paradox. You just have to accept that there's something coming backwards through time, and as a result, he's got no traction with this at all, outside a small group of people like me, I suppose. There's the Klein-Gordon equation with its negative time solutions. This is from a PowerPoint of his, and there he is, reverse causation and the transactional interpretation. So he's very much interested in reverse causation. He talked at a conference called Frontiers of Time, and that video I showed you was him outside the lecture hall of this symposium in San Diego about building starships. And you've got some big-time science fiction writers and some serious heavyweight scientists all getting together to talk about whether we're going to be building starships and whether we should be. And he was there because he's, well, I'll give you an example of the kind of stuff he likes talking about. Because basically, this has got him thinking about time travel in a serious way. I mean, this is him from one of his PowerPoints. I think he's quite amused by the fact he's on the front of a gentleman's magazine, the one credible scientist actively trying to crack that ultimate frontier, the fourth dimension. But he seems like a nice bloke, and he's used the melting clocks on his PowerPoint as well, like I did on my retro-psychokinesis project page. So it seems to be the thing. And he points out that this supposed law of causality is not really a law, it's something we build into the world. Causes must precede effects. But you know, there's violations of it in quantum mechanics. You can set up an experiment where clearly the cause happens afterwards. I'm not going to talk about him. There's another physicist into retrocausality. He's into something called chronotopology. I could go on about him. And he's allegedly had a shamanic initiation thing that he set up involving administering psychedelics to people, but it's all a bit hearsay, so I won't go on about that.
I'm talking about reaching the stars by accelerating a wormhole to very high velocities and shooting with the stars, and using relativistic time dilation to get there almost instantaneously.
So you fly through the wormhole?
You send the wormhole there, send momentum-bearing particles through it to steer it around where you want it. You land it, and then you expand it and get out and expose the planet.
I see. And how much energy does that take?
Nobody knows because nobody.
Anyway, this is the kind of thing he likes talking about, time travel. I love this, getting to the star by firing wormholes at them, not trying to go through the wormhole, throw the wormhole at the star. And he's using serious physics. He's writing what's called hard science fiction. That's like science fiction that doesn't bend the rules, that actually looks at the physics and says what could possibly happen. And he's hanging around with, like I said, some very heavyweight physicists and science fiction writers talking about building starships and throwing wormholes around. I think he's probably a little bit old to have been involved in the psychedelic revolution, but he seems to be quite compatible with it. That kind of thinking, I imagine, would appeal more to somebody psychedelically experienced than somebody not. But again, I don't want to make this distinction between sort of the sheep and the goats. I know some very rigidly minded people who've done lots of psychedelics who would ridicule this, but would critique it. And I know people who've never taken anything who'd be completely open to this. So that's an important point. I don't want anyone to feel left out. Finally. So what we look with the sort of paradox is that that Wheeler likes talking about involve things like this: tachyons and time reversal paradoxes. So you have something accelerating towards the speed of light, firing these particles, and they end up sending signals backwards through time. There's a thing called tachyonic anti-telephone. I love this. I wish I had one. It's a hypothetical device for sending signals back into your own past. And again, it's this: if you allow certain things in quantum mechanics, you end up with faster than light signals, which allow things to go backwards in time. So I'm going to end on a joke. This is, as far as I know, the only psychedelic physics joke. Why did the tachyon cross the road? It was a poem. And why did the chicken cross the Mobius strip? It's already on the same side. Right, I'll shut up now. Thank you. Hour and 10. I hope that wasn't too long for everyone. There's a lot of me talking. Anyway, if people want to ask questions, is that what we do now? Yeah.
What do you think is the difference? Obviously, some of the context you talked about, it varies. What do you think is the difference between the pull of the future and the push of the past? Because, like with the grooves example, you could just argue that that's the almost past force of gravity pushing it down, down the side of a wall, as opposed to something inherent.
It's a confusing. The Creole thing is a confusing metaphor for that reason, because you are using forward time physics to try and something familiar from forward time physics to try and give a sense of something coming backwards from the future. But are you familiar with Sheldrake's idea of morphic fields? Yeah, and basically, again, I'm not endorsing it. I'm very interested in it, and I think it's I find it very plausible. But he argues that basically, in some kind of mathematical, biological hyperspace, something somewhere, I don't know what you'd call it, every time something forms, every time something emerges or evolves, it could be a crystal, just the crystallization of a new type of crystal, or it could be a very simple life form virus or a self-replicating molecule. But every time it happens, it digs a little bit deeper into this groove in this what he calls morphic field, basically meaning the next time it happens more easily. And he gives lots of examples of solutions which will crystallize, which are very, very difficult to crystallize, and suddenly someone will succeed in doing it, and then they start crystallizing very easily all over the world. And then similarly, he would argue that a dragonfly growing from a single cell is being driven forward in time through mechanistic processes involving DNA synthesizing proteins and those proteins assembling themselves, but also it's doing something like rolling down a groove. And that groove is somewhere in some, again, sort of like I said, abstract biomathematical space of possibility, which is where it gets very woolly, because there's no model for this. But there are experiments that we do to try and to illustrate there's something along these lines going on. So it is, in some cases, it's hard to sort of, maybe, it's not such a simple distinction between the forward time thing and the backwards time thing. Perhaps, this is what the person I didn't mention, Charles Muses, I might as well just show his face. He wrote a book. It's a very strange book, and it used to be in the UKC library when I was a student. They've taken it out, which is interesting. Charles Muses changed his name to Museos and started this shamanic initiation movement. He was a sort of outsider Egyptologist, and wrote a book in a serious, it's a serious research academic text in. Published by Kluwer. It's completely legitimate cybernetics textbook, academic monograph, and it's about this thing he calls the interactive connectedness of time, or chronotopology. And I was very attracted to that idea at the time, because to me it suggested it wasn't about something going this way and something going that way, sort of rubbing up against each other. It was just one thing, like I was saying about the water moving around the rocks. You can't say what's causing what, even in that sense of directionality. There's something just. He wrote it in this very strange, kind of almost stream of consciousness way, with all sorts of references to mythology and theology, and bizarre. It's like, how did this book get past the editors? But it had insights about this, what he called descriptions, as he saw it, of this chronotopology thing. And I think he would probably argue it's not around anymore. That again, you can't make a clear distinction between what's between cause and reverse cause. It's just one kind of continuum.
Yeah. All of this sort of direction of time, you kind of had to. It's something we do. It's something that you have in there earlier on with the arrow of time and stuff. And I know, sort of, if you take sort of Einstein's stuff to its logical conclusion, that time itself is a dimension, like right and left, and it's already established.
Once, yeah.
So there's a block universe type thing that's already there.
There's a four-dimensional block that's got everything in it. There's no sense of an arrow. There's no time goes that way. It's any more than this line goes that way. That line doesn't go either way. It's just the line.
Yeah, right. And so, I mean, all of this sort of description about sort of time flowing in a certain direction is kind of ignoring that's already sort of placed earlier in your talk. That's just us perceiving it.
Yes, somehow our brain, our consciousness, seems to experience something like riding along this line in a unidirectional way. And you could say, well, if you were to look at this four-dimensional block, I mean, people might not be familiar with what I'm talking about. Once you say four-dimensional, people go all kind of sci-fi. It's a quite simple mathematical idea where, if imagine I had a pool table and I had a camera on the ceiling and I filmed every fraction of a second. I took a shot of this table that someone was playing pool, and I printed out all the every single image on a giant transparent, life-size transparency, so you could just see the balls, not the felt. And I stacked them all on top of each other in order. You would see the history of each ball's movement around the table as a kind of geometrical, sort of diagonally spiral up the thing. If the ball stayed put the whole game, it would just be a column. If it bounced around a lot, it would be that. If it went in a pocket, it would just disappear. But you could look at any ball and just say, oh yeah, so that ball started there and it bounced off that wall then, and then it ran into that one, and then it went in that pocket. So the whole history of the game, which is the metaphor for the universe, is in this block. Now, if you know that's a 2D universe, so pool table, effectively, the configuration is the 2D thing. We're in a 3D configuration. So we have the time in as a fourth dimension, we end up with a 4D block. You can't picture that, but imagine taking a photograph of a 3D photo, a big gelatinous cube photo of the universe. It's got everything in it, but it's all transparent somehow. So you have to probably have taken some drugs to really do this properly. And then you stack all of these 3D gelatinous blocks somehow together, but not blocks on top of blocks, but you stack them kind of all inside each other, somehow all nested, all lined up against each other in some other dimension. It makes this 4D thing. In the same way, you've got every single object in the universe and its history is there as a path. So you start off as a single cell when you're conceived, and then you expand into an embryo and a baby and a toddler and an old person, and then you disintegrate in a coffin. And you're a continuous sort of conical sort of wavy thing. It's not the right word. It's not a snake.
Time worm, I've heard it called.
Time worm, yeah. In the same way that if you took a time-lapse photo of me walking across the room, you left the shutter open, and I walked across the room, you'd see me as a kind of long blur. It's like a 3D version of that. And so, if you buy into Einsteinian space-time, the space-time continuum as your basic framework for the universe, it's just all there. The whole thing's happened, and in a sense that you're just basically saying it's all predestined. But then you get into problems with that, and then there are problems with interpreting quantum mechanics, and you've probably all heard about parallel universes interpretation, the many worlds interpretation of quantum mechanics. So there's a possibility that the universe isn't just one track, that there's a forking of the time track. But then when you hear about that, when you hear about time forking, it's always forking in one direction. It's like you're walking along the time continuum, you think, shall I do this or shall I do that? It's never forking the other way. You never have different histories converging on the same present. But this stuff, well, the retropsychokinesis stuff, got me thinking back then that there might be multiple pasts. This was like one of my most heretical ideas. I think some of my friends did think I was going a bit crazy. We all take it for granted that there might be multiple futures. It's like, well, I could do this, I could do that, and then you make these decisions and everything happens differently. And we often muse on, I wonder what would have happened if I hadn't done that. So that we see this as this fanning out. And I imagine we're walking through the woods and then you come to paths and they're forking. But imagine you're walking back, you're on your way back to try and get back to where you left your bike or whatever, you're walking along the path, And that's fine because it's been forking like this, so that you're always going to get funneled back to where you came from. But what if, as you were walking along, you didn't notice there was a path coming up behind you that joined your path? So you're going back, and you're, oh no, did I come from this way or that way? So again, I had this idea of different histories that arrive at the same part, same present, and that you can't know what your past was necessarily. When you attempt to measure that, I sort of try to tie this in with quantum mechanical ideas. And my idea was with the retro-psychokinesis stuff is that the past, those small parts of the past which are unobserved are basically up for grabs because there are lots of pasts all converging on the present, and just as there are lots of futures. So I saw it rather than a time as an endlessly forking line, I saw it as just this continually sort of, well, this permanent nexus of direct things coming in from both past and future. I don't know if I believe, well, it's not really a matter of belief, it's just a model, it's just a kind of sci-fi scenario really that I amused myself with. Does that answer?
Well, I mean, it answers it for me. It makes that block universe the most easy and sort of what are the parsimonious way to sort of deal with retrocausality, because all these other branching stuff makes it far too complex to explain.
Yeah. But if you buy into just a 4D block, then you are accepting, the completely deterministic set of laws.
Yeah, which I don't, but...
but you could still, it'd be interesting to try and relate, the issues of determinism and free will to questions of entropy and retrocausality. I haven't really thought about that. I haven't thought about a lot of this for years and years. I've sort of dug it all out again.
Do you believe that consciousness creates then?
Consciousness creates. I'd say that my general sort of suspicion about the world is that we've been educated to think that matter is the main thing. The world's made of matter, and consciousness is some sort of extra thing that comes out of that, what gets called an epiphenomenon. So matter gets organised in a particular way, and you end up with consciousness as a product occasionally when you get a higher life form involving more. So you've got consciousness inside matter, or inside the world of matter, you've got this phenomenon called consciousness. And it occurred to me that maybe it's the other way around. Maybe matter is a phenomenon of consciousness, because ultimately any access I have to it is through my mind. However I formulate it or model it or think about it, it's basically my mind organising itself into a certain way. And we share information about how the world works through swapping equations and models, and it's all mental constructs. So I started thinking, what if physical matter is an epiphenomenon of consciousness? And really, I think you can look at it either way or both ways, and the two are sort of co-creating in some way. Maybe that's just bully New Age nonsense. Ignore what I just said. But I think first of all, I don't think we have no idea what consciousness is, and I think it's got a much more expansive and mysterious role in the world than it's generally believed to. So to say it creates, I'd say I think I know what you're talking about, and I think I agree with you. So.
I'm just going to say that the bit you were talking about earlier about consciousness creating phenomena, I would say it's not necessarily just part of the New World perspective. Kant is very, very within that sort of a ballpark. He says specifically time. I think he would say forwards time. I don't think it's much of a concept of reverse time. He would say it's a predicate for all existence, ideas.
Was it one of his, what did he call them? They were the basic...
a priori.
The a priori, was one of those?
Yeah, so time was so like you could never imagine any action or any idea unless you had a specific amount of time for it to happen.
The duration within which it occurred,
but reverse time would work the same way. I'm saying that could just be two sides of the same coin. He's saying, look, these are both a priori predicates for existence.
Because he was actually, one of his a prioris had to be binned with the discovery of non-Euclidean geometry in the 19th century, because he basically took Euclidean geometry as one of his categories, and then Lobachevsky and Boilai and others came along and showed that there are other models. So, that was one of the rare instances where a philosopher was proved wrong by a physicist, because, normally things are fuzzy enough that you can still kind of prop them up, but that was wrong. So he could, I think you'd need to just sort of slight upgrade on Kant's a priori to include a retrocausation. But there's a question as to causation seems, it's like as I said, that when you look at the best evidence that this is something which is real and going on and affecting us at some level is the pre-sentiment data, the spike that appears before the picture shows up. But it's a muted spike, so it's not as if, it's as if the forward time half of the picture is more dominant, the backward time was getting muted. And Dick Bierman, one of the Dutch one on that team that did the pre-sentiment, he's published a model of consciousness. I might have it with me. He's recently, thinking, basically somebody who's been to psychedelic research conferences, done parapsychology research for years, and his new paper, Consciousness-Induced Restoration of Time Symmetry, a Psychophysical Theoretical Perspective. And he's basically arguing that starts from the assumption that information processing by a brain, while it is sustaining consciousness, so supposedly all of us right now, is restoring the break in time symmetry in physics. And I still don't quite understand what he's doing, and I won't read any more, but I mean out loud. But he's basically, I think he's suggesting that time, it looks like the laws of physics should be symmetrical, because like I said, they're all forwards and backwards, and yet there's a kind of break in that symmetry because there's this thermodynamic error of time. And there's this process that's kind of trying to work against that. There's a reversal of that, or it's an attempt to sort of iron that back out again. And when we see that bump mirroring the bigger bump, that's a physical, neurological trace of some process of this. I don't really get it, to be honest. I printed this thing out and there's like, well, this is handy, I'm going to have to look at this in time. But the concept of, he talks about his retro-psychokinesis experiments in here, and then about pre-sentiment, but there's sections in here, time paradoxes, does time symmetry imply retrocausation, this kind of thing. So there's a body of interesting literature if you know where to look about this kind of thing, by, as I see, reputable scholars, although of course there are always going to be people that claim that it's all lying. You have to sort of use some discernment because it's a very murky area. So if you look, some of the people I mentioned, if you were to look them up on Wikipedia when you got home, you think, oh, actually, they sound like a total fraud. They're totally, they're really sloppy, not proper scientists. And we'll look at what this person said about them. Look at all these references. And there are teams of people, like there's the PsyCop, the concerned scientists investigating claims of the paranormal, who organise people to form teams of editors and basically denigrate anyone that they deem an enemy of reason, which is a very limited concept, as far as I can see. So clinging on to this consensus reality. I mean, skepticism is good, don't get me wrong, I'm not just probably believing any old nonsense, but as Sheldrake points out, when you've got organised skepticism, it's really not much different from organised religion. If you're really skeptic, be a skeptic on your own, think for yourself. So, Rupert Sheldrake came to speak at Christchurch. See you, Kirsty. Thanks for coming.
I'll see you in a minute.
Sheldrake came to speak at Christchurch a couple of years ago, and I found, I was just Googling to try and find out what room it was in or something, and I found a skeptics message board, and someone was saying, how outrageous, Christchurch University allowing Rupert Sheldrake, total charlatan, non-scientist, to come and speak. Get in touch with the Vice-Chancellor and make sure this gets shut down. And there were people just piling in, what a fraud, and he's going to be talking about telepathy in dogs, ha ha ha. As if because Sheldrake's done these amazing, very well organised experiments with animals, like we all know, they can kind of tell that you're coming home when they don't know that, you come home at an unexpected time and someone says, oh, that's funny, the cat just went and sat up on the window. So anyone who's got cats and dogs for a few years notices these things. And he was like, well, let's experiment with that. Both of them were like, what a ridiculous thing to experiment with. And we all know that's rubbish. They can't be telepathy, and certainly not in dogs. And he runs these experiments incredibly well set up and very scrupulous science. We're talking. He was an Oxford or Cambridge biologist, and shows what we all know really, that yes, there does seem to be very strong correlation. Similarly with breastfeeding mothers, when their babies are away and need feeding, that they start crying at the same time that the mother can actually feel the sensation in her nipple. So Sheldrake's like, that's interesting, let's experiment with it. Other people like, what a charlatan, he's promoting ideas like telepathy. And so there's people going, LOL, Sheldrake thinks dogs are telepathic, yeah, let's shut him down. It's like, you haven't even read his research, and you're telling people to get in touch with the Vice-Chancellor. This is like fascist tactics. So anyway, rant over. But basically what I'm saying is if I sparked an interest in any of this stuff, and you go online, and it suddenly all starts to look like a load of bullshit, use some discernment in who's written what you're reading, and it's ideologically charged material. It's like reading about Israel or something, passions run very high on both sides for some reason, because we're talking about the boundaries of what's real.
Could we make the slides available on the Facebook page?
Absolutely, yeah, that's good, because then you can follow up,
Well, it's quite interesting that you didn't talk about the results of your own experiment.
Well, I kind of lost interest. I mean, there's, like I said, the data was very dilute. I haven't looked at it for years and years, and I was basically convinced that it wasn't going to create any statistically significant results because of the way I'd set it up. And at that time, what was going on? I was an honorary research fellow in the Religious Studies Department under Peter Moore, as I said, working in Darwin Computer Room back in like 20 years ago. And I started getting emails from someone who I suspect was schizophrenic, who thought I was sending signals backwards into his past. And it was getting like, I was a bit weird. It was before, the first instance I'd experienced of just really weird stuff going on online, because as I said, up to that point, the web was very utopian and very like cooperative. And suddenly things were starting to turn a bit weird on the web, and I was getting this, and my mind was in quite an open state a lot of the time, shall we say, so I was, it was a bit like, oh, this is getting weird. I think I'm just going to let this run. Someone else can worry about the statistics. And I went off travelling and playing music. So you could actually, it got referenced in some parapsychology conferences in the last about 10 years. So you could probably find out what the results were. But I think
has anyone tried to punch the numbers?
Yeah, I think so. I think what happens is it gets integrated into a little meta-analysis. So you analyse multiple experiments. So I think it's all churned away inside some great meta-analysis. Any other last questions? I think I've been keeping it. Eric.
The question I found fun to ponder is, if physics is time symmetric and we can remember the past, why can't we remember the future?
Why can't we remember the future? Yes, there are asymmetries when it comes to consciousness, clearly, in terms of, like I said, all of those instances of the arrow of time are to do with knowledge states, whether it's entropy or to do with quantum mechanical wave collapses. If you took us out of the picture, that arrow is very tenuous. And so, our minds do seem to be asymmetric. We do remember the past but not the future. Occasionally there are some striking examples of precognition. Of course, if you're a skeptic, you go, well, of course, by some statistical law you're going to get anomalies occasionally. But there are some really very striking examples where, and I think we've all had anecdotal experiences personally that kind of hard to explain away of precognitive, just little flashes of things before they happen. So it's possible there is an element of remembering the future, but it's very muted for two reasons. One is that we haven't got a language structure to accommodate it. In the second, if you have a word for something, it's kind of not there. If you're an anthropologist, I think you know what I mean. I don't know exactly what I mean, but I know there's something in the fact that, I think Timmy was saying earlier, structuralism, the idea that your language shapes what is real, what your reality consists of. So if all our language structure is about time flowing forward, like just paddling along a tram, then that's going to affect what we perceive and how we structure that perception. If we started to develop a language structure that could accommodate reverse time effects, then we might start to notice them more. But on the other hand, there's also seemingly, just from the data, from the pre-sentiment data, there seems to be a muting. It's not big spike before the picture and big spike after. It's like there's a mirroring, but there's also a downscaling of it.
I was just follow up with so could you say something but like deja vu is sort of something that you could say is something that's in the future, like it's a really muted effect, but it's something that when you get into a certain point, it's like, actually no, I thought I remembered this.
There have been various reductionist attempts, neuroscience attempts to explain, neuroscientific attempts to explain deja vu using, some kind of, it's about some time delay between two parts of the brain or something. I haven't really looked at it. But my sense is it's probably, because I do believe that there are retrocausal. I think the world makes sense if you accommodate some kind of retrocausation. It seems to work at the level of physics. I think Sheldrake's onto something with the life forms, and this pre-sentiment data looks pretty convincing to me, and I feel like I've experienced it. So, I think the world has got some kind of retrocausality in it, and it wouldn't surprise me at all if deja vu was just one of those little glitchy sort of insights that we all get, that everyone knows what you mean. I've never met anyone who's like, I don't know what this, maybe once I met someone, but you don't meet people like, deja vu, what's that? I don't understand. Everyone gets it. And it is mysterious. It's got an uncanny feeling about
because then we've actually got a word to talk about it, so people actually understand. You understand when you mention it in a conversation. conversation, people actually know what you're going to
Yeah.
talk about.
Yeah, whereas on some other weird thing you might have, you take certain drugs and you come back and you're like, that's this weird thing, but you haven't got any word for it, and so if someone else might have had the same experience, you're never going to know that you have because you can't share the word. So that's a whole level of this that I'm not qualified to explore really. It'd be really interesting for some philosophers of science to talk to some anthropologists and linguists and things and really like unravel all of this. I'm just dabbling here, and as you can probably tell, I'm not really qualified in anything other than maths. I like talking about stuff. Any more questions?
What about paradoxes? If you're talking about things like retrocausality, eventually you run into the problem where you get an infinite feedback loop of reality, and just how do you untangle that?
There are John Kramer, the video of the physicist. He's looking particularly at that about you get these sorts of restrictions and boundary conditions on what's possible. It's not so much that the future's causing the present. It's a subtle difference. It's that the present is somehow dependent on the future. There's a kind of relation between them that is, which conventional science doesn't recognise, which means that what the present can be like is conditioned by how the future is going to be.
That supports determinism in a very significant way.
Don't I erase that definition. I don't think that's a good example, a good account of it at all. But it's, these paradoxes have been explored, and I'm not the person to ask, and this is getting quite technical. So, but check out John Kramer's work because he's written extensively on it, and he's not evangelical with it. He's not claiming to have invented time travel, or that he's about to, or he's not got some big crazy theory that he wants everyone to believe in. He simply said, hey, we can make sense of quantum mechanics much more smoothly and elegantly and beautifully if we just allow this backwards time thing. And then once you let that in, then it's like, then you can look at this that way, and then time travel starts to seem a little bit less ridiculous. But there are, the paradoxes have to be resolved. The famous things like if you travel back in time and kill your grandfather, you create impossibilities. So then how could that sort of thing be restricted? Could you ever physically go back in time? Again, there's a whole area of speculative science around this stuff that I've not really looked at. I think
considering what you showed previously in the picture where you have the spike in the reaction for the image, and you have the slight difference in the gap.
Yeah.
To me, this kind of weirdly seems like a ripple effect. If you can imagine, like, time as a sort of field or whatever, and if you have a sort of ripple or event, it affects the locality around it, and thus you can find, like, maybe in the future, and that's obvious, in the future you're influenced by an event.
It's like throwing a pebble in the pond.
Yeah, exactly.
The time ripples. It's like we are looking at ripples of a splash. Yeah.
Exactly.
And the bigger the splash, the more you feel it. Hence, the image has to be quite shocking. And you throw a big brick in the pond, and it really, and I think that's why I say there was a lot of precognition. Often with these big disasters, plane crashes and 9/11 and things like that, you can get more stories of precognition than usual, it would appear. Again, this is all anecdotal, but because it's almost like such a huge thing is thrown in the pond that the waves are so enormous that even though people are very insensitive to this stuff, a few sensitive people pick up on it.